As far as what we've gone over in class so far, does everybody seem to be pretty comfortable with it so far? As far as the things I've been giving back to you, the feedback and such.
Kind of.
And, well, and you can get with me offline, like tomorrow or anytime, and we can talk about what I'm showing you. Remember that there's gray areas in this, so I might see something that you might see, that kind of thing. So it's hey Brad, how's things up in Amarillo? But you'll see different things that I might see. I might see different things that you might see. So that's how that comes about. But today we're going to talk about the fire and explosion scenes. We're going to talk about what we're looking for to identify potential evidence, that kind of thing. And when we do the scene exams, we have to think about it and understand that we're analyzing evidence, locating evidence, recognizing what evidence is. And the whole idea is for us, we have to be able to formulate a hypothesis, an educated guess on the area of origin and the cause of the fire too. And as to we have our hypothesis also has to come up with who or what might be responsible for the fire that came about. As far as that goes, you look at the conditions when you're doing the exam, location and condition of potential evidence. What potential evidence might be? Uh, the extent of the fire explosion. If you can get there when it's burning, you're going to be a lot better off because you're going to be able to see fire movement and that kind of thing. And you'll be able to see if it's fire department operations that's causing the movement or if the fire is moving because of certain things. You'll want to know where the utilities are. You want to look inside to see once you get in there. You'll be looking for evidence of explosions. You'll be looking for things like relocated contents. Think about people moving furniture. Think about fire department personnel moving furniture around, that kind of stuff. So you'll want to be able to understand where it was before the fire started, that kind of stuff. And we'll talk about that later on today, that kind of stuff. But the whole idea is the complexity of the fire scene or explosion scene all relates to the scene size, the level of safety, the number of investigators you might need. Even the fire department operations makes a big difference because the fire department operations can change. And I hate saying it this way because I've been a firefighter for so long, but but the fire department is probably the best source you have to tear up evidence. It's that simple because what they do generally is they take things out, they throw things out, and so on. So we can educate firefighters. It helps us with the investigation, and we have to look at the time that between the fire and the investigation that is taken to get in there and look at it. Is it immediately after? Is it 2 days after? Whatever it might be. Then you have to determine the location of witnesses, potential sources of ignition like heating, vent systems, HVAC systems, appliances, electrical systems. All these things have to be looked at by an investigator to figure out the potential for ignition and the potential for evidence. Uh, you got to kind of figure out the whole overall condition of the scene. And you have to record these things on field notes, uh, photographs, video, and even descriptions, written descriptions, or audio recordings of the scene. Main reason is you want to be able to remember, memorialize, I guess is the best way to put it, the scene. You want to be able to remember that scene. And you in doing this, you have to use the scientific methodology. That's the number one thing that we use when we do fire investigations. It's the same systematic and consistent processing of a scene that you do on every scene. If you do a right hand, a left hand, you go from the least damage to the most damage. You go from outside to inside. Those kind of things, you need to learn to do them the same way every time you do it. As far as evidence goes, there's so much different types of evidence in there. It was there forced entry? Was it done by the fire department? Was it done by someone else? Are there empty containers around the scene? Do you see indications of multiple areas of origin? Do you see footprints, boot prints, debris where it shouldn't be, evidence tampering with utilities? Any number of these things can be part of that. And you have to look, are there tool marks? Is there ignitable liquids? Uh, is there glass outside of the windows that are broken? Because usually firefighters break them in instead of blowing them out. So you have to find out if they broke them in to get in, or did they break them out, or were they broken in prior to the fire department getting there? And you have to look at fire patterns, the different fire ways the fire travels. You have to understand that fire patterns and such tell a story of where that fire started and where it went. Look in there. Do you have incendiary devices? Is there absence of contents in that building? Think of this: people that normally burn up their houses don't burn up their stuff in their house. So look at the closets. Do closets have clothes in them? Do they look like new clothes? Do they have have pictures throughout the house? The things like that that you want to look at. And when you analyze this kind of evidence, you're using scientific methodology to maintain an objective and open mind regarding the collection and analyzing of evidence. Now, when we think of evidence, we also have to exclude things too. We have to exclude, uh, for instance, if you find carpet that's burned, you might think about taking a burned area and a sample area that's not burned to see that there's not that somebody may have poured an ignitable liquid where you're picking up. Uh, you have to think of things, and you have to rule out a lot of things before you can actually get your and keep an open mind eh, before you get your evidence to be corroborated. Uh, and evidence might tend to indicate a suspect or even a motive, and don't exclude other evidence that might prove different cause or suspect, or disprove a different cause too. That makes a big difference. So when we start, we're going to look on the outside, right? We're going to look on the outside of a of a container. I guess we'll call it a house fire. A house is a container, okay? A room in a house is another container. All these kind of things. So on the outside, you're gonna look at the types and the extent of the fire suppression activities, the fire behavior, uh, ventilation, specific fuel packages inside, location of the fire. But you can see it where it's going to be burning the most, usually in the area of origin, usually. And even look around for the responsibility of the fire. On the outside, you take photographs 360 around this fire and think about taking it around the area too. We've actually caught suspects because a lot of them like to go back and look at their fires. And if you have a whole bunch of fires, let's say a serial arsonist, you might catch them that way. And we have caught them that way before. On the outside, look at things like vehicles. If it's wildland or grassland, where does fire go on the outside anywhere? And it might be some exposed part of a wildland fire that caught this house on fire or this container on fires. So look at the protocols for exterior exam when you're looking at it. Look and document the fire and suppression activities when you're looking at the exterior of a fire, of a say a container fire. Uh, if evidence is observed and the location is, if you're not able to secure it or protect it, photograph and document the evidence. Measure the location of the evidence from a fixed object, a wall, two walls, so you can triangulate it in the middle. Because during overhaul, they may move this stuff, or you might not be able to recall where it was if, say, the bed's moved out of the way or somebody moved the bed. So triangulate from two fixed objects and collect that evidence as soon as you can, and find who moved. If things are moved on the exterior of the house or the interior house, find out who moved that stuff, whatever it is you're looking at. Did the fire department move it? Uh, did passersby move it? Did curious non-producers, did they come by and say, hey, I think need this, or I'm going to move this out of the way? Any number of these things. Find out if somebody moved the cars. It makes a difference when you're doing the entire investigation. Look at your building utilities, the electrical, the water, the fuel, and just figure out if the utilities were operational when the fire started. If the electricity is not on, you know, or the gas is not on, it's not likely that it's going to be an electrical fire or a fuel-fed fire from natural gas. So you got to ask these kind of questions. Uh, your ignition sources are reduced if that way. Uh, it might even be, if the utilities aren't on, it might tell you if it was occupied or not too. And then again, you look at things and document if there was tampering, removing of safety features, booting of electrical, running. Uh, say we've seen them run and tie in electric cords into a box. We've seen them where they use a metal instead of a fuse or something like that. So all these kind of things can happen. And has there been any activity of the from the power company that they disconnected that service? Look at the building systems on commercial buildings. Well, and some residential. Look at the fire department connections. But are they working? Do they work correctly? Uh, is the alarm signals working? Uh, is the heat pump and air conditioning units, or did they shut down? Were they shut down by the fire department, or were they on? Look at your chimneys, look at your vents, all these kind of things in the outside of the building, uh, and just look at them to figure out if their involvement or lack of involvement in an ignition scenario that you might have. Then we look at things like the interior exam. The interior exam, we want to look at things like fire behavior, building construction, anything that we can, and track the spread and direction of the fire's movement. We're going to go over some fire patterns here a little bit later, and we'll discuss those and movement of fire. Compare the observations and the fire suppression efforts. I can tell you I've fought fire enough to know that if I put a fog nozzle into a large fire area and it can move around behind me, it'll do that. So we have to understand that firefighting and suppression efforts can move fire along. And look at that. Look at the origin of the fire and examine the interior. Be systematic. Do your initial assessment first before doing a detailed exam. uh, Begin at the least damage area and then go to the area of greatest damage. That way it kind of gives you a pattern which way it's going. Uh, Things that you might want to detail are the building contents, the appliances, the position of the controls on the appliances, especially when you have kitchen fires and that sort of those kind of fires. The building utilities inside the building, you want to look at the breaker boxes in there, and whether you want to reconstruct the scene or not, before pre-fire to see where things were and recognize and document and preserve the evidence. All potential evidence that are seen during the entire exam should be documented and preserve that evidence and recognize the evidence that might refute or support findings as in the origin and cause and the responsibility for that fire and preserve that uh, and eliminate other causes. Because if you have to go to court on these, they're going to ask you, is there anything else that possibly could have started it? Well, the answer most times is going to be yes. However, the whole idea is to eliminate those other potential causes. When we look at these always remember scientific methodology and think about explosions of physical damage, the type of fuel that's involved. Is it lighter than air? Is it heavier than air? Are there liquid vapors? Was it a dust explosion? Were there secondary explosions? Was it a backdraft, a smoke explosion, or a BLEVE? Anything like that? That are things you want to document, and you want to describe and document the damage by answering: were their walls shattered? Did they bulge out? Did they fall over? Was their masonry broken? Were the steel members uh, bent in a steel building? All these things are questions to ask. Look at things like glass. Is there soot on the grass? On the glass, I mean, not grass. Did the fire occur between an explosion, or did the fire occur after an explosion? If there's no soot on either or other damage on glass, then kind of proceed to fire, that kind of thing, because usually glass is going to break out during the fire. So go to the fire. Just remember, pressurization, well, even of a quarter of a pound per square inch, will it'll shatter glass. So you should see shattered shard uh, or shattered shards of glass if it was an explosion. Look at the explosion again. What is it? Huge, widely dispersed uh, explosion. Is there splintering? Is there fire inside? Was there fire on the outside and not on the inside? It all tells you things about your explosion. Uh, and look under at things. Are there embedded things? How hard were these items thrown? That were they embedded in the walls, under rubble, that kind of thing? And look at the clothing and injuries of people at an explosion scene. Think about the areas and how big they have to be. A lot of times you have to set up grids and secure huge areas for explosions. You have to flag the evidence on the grid and for just to have good, accurate documentation. And think about the vector analysis too, using geographical tools and those kind of things. Look at your origin and figure out things like seeded explosions, like the high explosive type seeded explosions. They're more easily identified than the deflagrations, because the deflagrations burn a lot of the evidence. So therefore, you have to work harder at those. And think of the area of the greatest destruction that involves a deflagration. Uh, Explosion dynamic. Look at those things, and the vector. Look at the force vectors going backwards towards the initial compartment where it started. Start from where the end of it and come back. Look at the explosions that involve secondary explosions, like the dust explosions, like the gas utilities and such. Look at those and see if there were leaks or anything like that there. And look at the different ignition sources and identify what they could have been. Was it fuel that hit an arc where there was electrical energy? Is it a gas vapor where it finally found an ignition source, something like that? All these are things that can be determined, but they're things that we have to look at when we're looking at fire and and explosive exams. So there are things that we want to think about, and these are just a few of the things that we have to look at. And when we look at them, we have to understand that there's going to be a lot of different questions that we need answered and that we want answered. We're gonna move on to areas of determination, origin, and determination. Does anybody have any questions over what we've gone over so far? I guess I'll take that silence as a no. Okay, but if you have no questions, we'll go ahead and move on. Uh, Chapter 14 is we're going to talk about the scientific basis of the effects of fire and fire patterns. And I'm going to actually show you guys some fire patterns, and we're going to talk back and forth about these fire patterns. I'm not just going to show you the pictures. So when we look at determining the area of origin, we have to think about the area that the potential ignition source and the materials that are first actually came together for the first time. What we're analyzing is basically fire effects and patterns, fire behavior, any witness statements that you might have, and physical information. Think of witnesses though. Don't just think of if there's anybody out there that starts who called. Did anybody here call this fire in? If people are raising their hands, you want to see what they saw and think of perspectives. Well, where were you standing? Where were you when you saw the fire start? These kind of things, because perspective one might be different from perspective three. Think, when you're talking to them, you ask them what kind of business you're in. I'm a builder. Well, a builder might see something different perspective than say an attorney over here that saw it first start. So think about those kind of things when you're talking to witnesses and getting information. When we look at the scientific basis of the fire effects and fire patterns, the primary factor in fire pattern creation is the amount of radiant heat flux on a material's surface. Okay? A fire plume and heat flux basically are the primary means of the patterns of production of these fire patterns. And it's in the early stages of fire, and it keeps moving throughout the fire. As fire continues to burn, the upper layers begin to form, and then they start transferring heat down the wall and down the ceiling surfaces, or from and down and across the ceiling surfaces. I'm sorry, and basically, the plumes when they make contact with the interior finishes of that building, what it does is it changes the surface content, and it all depends on the surface content too, as to how well these plumes and what kind of patterns they're going to make. The temperatures in the upper regions are going to be a lot higher than those lower down. I mean, you can have anywhere from 300 degrees down on the floor to 2,400 degrees or more up on the ceiling, depending on how high the ceiling is. And you're gonna see different heat flux type patterns on the walls. Uh, and basically, when the plume reaches the ceiling, basically a lot of heat is transferred to that ceiling, and it'll come back down the wall. And as it goes back down the wall again, it's gonna decrease in heat. So thermal layering. The hottest and biggest damage occurs directly above a plume. Fire patterns are more distinct over a plume, and basically, fire comes in sequences. Basically, there's ceiling jet and gas transitions through flashovers that'll involve an entire room, and what that does is basically it heats up the entire room, and it flashes the entire room. It flashes all at one time, and everything catches fire at one time. The upper layer expands out, and basically it hits the floor, and the whole compartment lights up. And basically, when you transition from full room involvement, the fire transition, or when you move to full room involvement like that, the fire basically transitions from a fuel limited to one that's ventilation limited. Uh, Basically, how much oxygen is in that room. So therefore, if you introduce oxygen into that room, it can cause it to flash over. So therefore, you'll be able to see. And ask the firefighters, did it do this before you came in, or when did it do it? With limited ventilation, basically, the areas that have the most intense heat, have the greatest damage, are the ventilation portals, the windows, the doors. The location of the most damage is not always going to be the area of origin, specifically if there's at ventilation areas like the doors, the windows, that kind of stuff. As far as the way flames go, understand that it's not always going to be where there's the most damage if you have ventilation ports like windows and doors and that kind of thing for the heat and fire to get out. Now, we've talked a bit about exterior fires, and when we're looking at fire patterns exteriorly, think of things like low level burning. Look at that really close. Low burns might be the result of a fall down or drop down of say sea, roofing materials or something like that, and might be caused of secondary fires, or it might indicate an area of origin, and it might even result in fuel, like for instance, if asphalt were to fall down, you're going to end up, that's going to be an ignitable liquid, right? So therefore, we have to think of things like that when we're looking at exterior fire patterns. Just analyze and document those fire patterns and collect and preserve any evidence that you might find. Now we're going to talk a bit about fire patterns, and we're going to talk about what they look like and such here in a moment. As far as fire patterns go, it's visible physical effects that remain after a fire: burn, charred materials, uh, smoke stain, soot stain items, distorted, discolored, melted up materials. All these things that form on interior surface walls, floors, ceilings. They're caused by heat. They're usually caused by heat, and the method of transfer is by either conduction, convection, or radiation. There is nothing new there. Do they have visible boundaries or borders where heat energy impacts the surface? It indicates the history and longevity of the fire too. They might assist in determining the history of the fire, because fire patterns tell a fire's history, where it started, where it went to, that kind of thing. And it also tells you the path of fire travel too, because remember, fire burns up like that, or up either way, or up and out. But the whole thing up is fire burns up. And think about how it works, and look at it that way. Uh, you're trying to correlate and propagate the considerations that you have where this fire started and how it started. Think about this too. Rough surfaces are going to be more heavily damaged than smooth surfaces because there's more surface area to contact. So when you're looking at that, think of things like the turbulence they might cause on rough surfaces. Like say for instance, a sheetrock wall might have more damage, say, than a smooth paneled wall or something like that. So look at that, because it's rough and the other's smooth. It's not always going to be the fact, but think about that when you're looking at it. We're going to look at some fire patterns. We're going to look at some plume generated fire patterns. There's ventilation generated fire patterns, or suppression generated fire patterns. There's even layered hot gas layers too. You have clean burns, you have pointers or arrows, irregular patterns on floors, saddle burns, protected areas. All these things are part of fire patterns. Now I'm going to go ahead and we're going to do I'm going to do some sharing over here of my screen, and we're going to look at some different fire patterns. Okay, so I'm going to put it over here and make you guys responsible for telling me if you see these patterns or not. Okay, So can everybody see the patterns on the screen here?
I can see them.
Okay, so first off, we're going to talk about the plume-generated patterns. The plume-generated patterns, well, when you look at this down here, these are going to be kind of tough to see, but when you look at them down here, you have an inverted V pattern. We're going to talk about how those are generated and how we're going to look at them and take care of them. A plume-generated pattern is basically a cone shape which originates above the flame where the fire is in, when the fire is in its incipient stage, right? If it's near a wall, basically you're going to get vertical artifact, and basically the hot gases go up and over the surface and create that pattern. The patterns produced by plumes, they're kind of geometric shapes. If you look here, this is going to show us an inverted V. See right here, we're going to have a V. Oh, let me do this again. Sorry about that. But sorry about that. But your V is going to be along here, your inverted V, and make like an hourglass type thing to have a V pattern up on top. Does everybody see what I'm talking there about? Does anybody see what I'm talking about?
Yes.
Okay. So therefore, this is going to be a back and forth, or I'm not going to do it, okay? Because I got to show you guys these things and understand that you understand this. So when you look at the cone shapes and that kind of thing, you're going to see things, and I'm going to show you some more here, where you're going to see things like lines of demarcation on the wall, and you're going to look at these patterns and understand that these patterns are there. Now I'm going to show you a V-shaped pattern. And the V pattern, when you look at this right here, see how this V pattern comes up and across here? And it shows if there's photographs on the wall, if see how your studs are burned out like this. Everybody see that one there? And what it does, it means that the V, the very bottom of it, is closer to the fuel package, and basically it's sharply angled. When you look at V patterns, you'll find them in corners like this. If you had something catch fire, it would go in both ways. Okay? Does everybody understand what that V pattern looks like?
Yes. And that one's
Yes, sir.
pretty much facing or indicating that it's arcing vertical.
Yeah, this one definitely is coming up and across in a V pattern. Now, I'm going to show you a few here in a minute that might show a little something. Some people might call this a pointer pattern too on this side, but it's actually a V because you can see it coming across here. Okay? A pointer is showing you which way the fire went, but in this case, the fire went up on both sides and across the ceiling up here. Okay, so everybody with me on that?
Yes.
Okay, good deal. Now we're going to talk about a U-shaped pattern. A U-shaped pattern is a little different. A U-shaped pattern, basically, a U-shaped pattern is kind of similar to a V, but what it appears higher up on the wall. If you notice this here, how much higher up it is right here. What it means is basically the fire flame zone is further away from the vertical surface. So the other one, your V pattern, might have started up next to the wall, where this one here might have started a few feet away from the wall, and the pattern got up that way. Uh, the fire might have been 3 or 4 feet away, where a V-shaped pattern like this one here, you can see it's going to be closer and lower to the wall than this U shape. Okay. So when we look again, we're going to look at the hourglass type shape. So again, you're going to have this inverted V here, which means your pattern, your fire started out this way some, came up and then made a V pattern. So your fire origin, if you have fire, most of it's going to be out in this area. Does everybody understand what I'm saying there? It's similar to the V and the U, but so you guys see what I'm talking about there?
Yeah, I see it.
Yeah, and the reason
Yes, sir.
reason that happens is because the fire has to come in before it goes up. So therefore, it starts or the pattern is a good distance away from the above the floor. So it could be caused like say a coffee table or a an end table or something like that could cause that type of. It's basically an inverted V with with a normal V shape on top is what it is. So uh, so any of those things could cause that type of shape. Now, whoops. So this next one, I kind of messed that up. Didn't I? There we go. Let's go back to this. Let me bring this back over to you. Did that get small?
Yeah, I got small.
Let me see what I did. Oh, I hit this. Well, let's make it bigger. There we go. So next thing we're going to look at is circular shape type patterns. Now the circular shape, basically it has this round circular area here on the bottom. Let me bring this up a little more. But when you have a circular shape, you're also going to have a circular shape on the ceiling. Why is that?
Because the fire is in the center of the container and it's burning up, creating a circular burn. I guess heat's just radiating to the ceiling.
Yeah, exactly.
Creating-
Because the plume's going up, and that's where your heat's going to be at. Uh, because it might be because of ventilation, it might be things, vertical impingement. There's no telling what it might be. But when you have these, you'll also see these on these other other circular type shapes in corners and stuff like that. You'll see them too because of the vertical impingement. It makes it go up. And then we have these things like inverted cones. Now, inverted cones, what they do is they're a little different because they look a little different. When you're looking at things like, let's see, did I even put an inverted cone on there? Let me talk to you about an inverted cone. Basically, an inverted cone is an upside down V, and I forgot to put one of those. But the base of the fire is widest at the lower part of the fire pattern, and actually, I think I can bring one over here. No, it won't let me. But anyway, it's the whole idea is you have a wide pattern, and basically a lot of times there might not be a good fuel base at the bottom, but it indicates maybe ignitable liquids was poured along the bottom or something like that. It's short-lived because it doesn't reach the ceiling or any type of horizontal obstruction. It indicates the wide patterns at the bottom indicate low heat release rate. Uh, Even if the fire was extinguished in the incipient stage, you might see something wide at the base. Uh, it can be anywhere from gas to propane to natural gas, any number of things like that. Uh, other things I want to show you here. Well, I want to show you a few more. When you look at this right here, this is a pour pattern here. When you look at different things like this, you have to decide, is it pooled or is it actually a pour pattern? See how we have this burned areas here? Right in this areas here? You have
Yes.
to ask yourself, did something fall down and cause those patterns? Or what else might have happened? What else could have happened there? Could somebody maybe have poured something on the floor?
Yeah, that's what it kind of looks like. It looks
Yeah.
like liquid got poured down and burned.
It could be any of the above. Thank you. Uh, and I appreciate it, Kyle. the whole idea here is to discern why these patterns are here and what they are. When we look at these, we were talking about the pointer arrows earlier. Um, Basically, your pointer arrows tell you the direction their fire is going, or any number of things. Your fires typically start low. Everybody understands that, right? Well, typically, this is going to tell me the fire started down here and moved its way up this, up this right here, and that's the direction the fire traveled. Is it going out towards a ventilation port, or did it go back across another wall, or whatever it might be? These are arrow type things. Try to recognize the difference between an arrow type pattern and a V pattern. You're going to have arrows on V patterns, but your V patterns are going to be on both sides. Your arrows are going to be on both sides. So I want everybody to understand that for sure. As we're looking along, we're going to look at things like saddle burns. These are unusual type burns that you might see on the top of rafters, that kind of stuff. And usually that's going to indicate that your fire may have started in an attic or something like that. It also indicates that there's a lot of heat in that attic too. Don't let it throw you off, because fire can go up and get into attic a different way, and I'll explain that. I went to a fire with one of our investigators a couple of years ago. He actually called me and said, "Hey, dude, you're close. Can you come by and look at this?" And I went by with him, and he thought it started in the attic. And I said, "Let's look down here." There was actually a burn pattern down low. Well, when we started looking, we saw the fire pattern began underneath a nightstand. Well, when we looked at the nightstand more closely, we found a rolled up and taped up extension cord that apparently set the bed ruffle on fire, went up into a window, broke the window out, and went up and got in the soffit and got into the attic and caused these saddle burns. But you're going to see different things, and you might not see everything when you first walk in. So kind of look at different things when you go into these fires. So yeah, it's not always going to be what it looks like. Then you have clean burn. Who can tell me what causes clean burn besides Kyle? Anybody? Bueller? Jonathan, what causes clean burn?
It's excessive heat. It's a high heat.
Okay, that's right. It's where everything's burned away, isn't it? It's excessive
Yeah.
heat, right? Kyle,
It's on sheetrock, so be burning the paper, burning the paper content on the outside of the sheetrock away, taking out all the moisture. Now it's burning the surface, I guess the chalky surface of the gypsum board.
Okay, you're right. That's exactly what it is. Uh, can Ismail, can you tell me why it does that?
Well, I think like he mentioned, right? You know, the heat being, I guess, fast.
Right. And you're right.
Temperature being high.
Yeah, your temperatures are going to be higher in this area, right? So that tells you you have heat generated stuff here. Is that necessary? Is that necessarily from direct flame impingement? Anybody?
I'm sorry. What was the question?
Is that primarily from direct flame impingement, or is it from thermal layering?
I would say no. I think it's more from thermal layering than the actual exposure to the flame itself.
Okay, yeah, it can happen. It can happen either way, but usually you're going to get more fire type patterns if it's going to be direct flame impingement, right? So you're going to get different types of patterns. It can be, but it's doubtful. Okay, so let's look at the next one. When we look at thermal layering here, we were talking about, oops, yeah, darn it. Let me get back to it. When we look at thermal layering, I got it too big. Let's look at these things right here. Look at your ceiling. Your fire probably started over in here, right? Just look at your arrows and that'll tell us. But look at the thermal layering, the way it goes up and across. Okay? See how hard it's burned up here? Everything's burned away. But as it comes down, it starts lightening up a little. It doesn't do much in this one. But as it comes down, you can see over here, you have a little bit of a clean burn right in here. See how it burned away stuff right here?
Burn
Anybody?
paper.
Yeah, like your wallpaper or whatever it might have been. But you come across here, see how it lightens up a little bit as you come down? Not much, but it comes down a little bit. You can see you probably had a protected area right there that was probably picture or something right there that was saved. But see your V pattern on this one here? See how it came across? See how your burn comes across here?
Yeah.
Okay. So that's going to show you some thermal layering over here, how it came across. But you can see here your burn pattern is a V pattern coming from this point right here. Okay. So as we move on, I want to show you some.
What about all that charring that was right by that protected area, that part that you said was protected?
What this right here more than likely is going to be thermal burning, charring of the. It depends on what it was that was there. It might have been sheetrock. It could have been paneling, anything like that. But as you see, there's no direct flame impingement on that. Your direct flame impingement stops right here. See,
Yes.
and then your thermal layering starts over here. So your fire came up and across this way. Everybody
Okay.
with me on that? If you can see along here, you can see some thermal layering up on the cabinets a little bit too. Okay. See how it's lighter coming down on the cabinets?
Yeah.
It's not a very good picture for that, but is there any questions about this one?
No.
Okay.
No, sir.
So as we look here, these are we have to think about when we look at these pour patterns, okay? When we look at pour patterns, think about this. One's on carpet and one's on concrete. They look somewhat the same, don't they? But notice this one over here. See the little edges out here? What do you think these little things on the edges are? See how they're lighter?
It was because the fluid was pulled in the middle, and it was burning. It was burning the vapors on the outside of the of that pour pattern.
Exactly, because it's cooler in the middle where they poured originally, isn't it?
Yes.
So therefore that's what you're going to see. If it burns, it tells you if it burned a long time too, because we've seen pour patterns where they were put out right away, and you'll have melted areas throughout, but you won't see any soot or anything like that. This one here, you'll notice that it splashes a lot more than it does over here, which kind of tells you that this is probably a concrete base over here, something like that. And you can see which way your pattern went, can't you? All the way out into here. It's when you look at it, it's possible that they may have poured a whole bunch of it right here, same as here. But the whole idea is to recognize what a pour pattern is versus a drop down pattern. Everybody understand what I'm talking about there?
Yeah.
Okay. So that's all I have as far as fire patterns go. And what we'll do is keep on going, moving on. Uh, understand that these are not going to be all of the patterns that you're going to see, because there's the irregular ones like the curved or pool shaped patterns, that kind of stuff. You get ignitable liquids. Think of what stuff's made of too. Uh, Sofas and chairs nowadays are made of polyurethane. Well, when it melts, it pools in and around the furniture, and it creates like a hot gas flowing onto the floor. If the floor is not level, then it's gonna flow down. It may look like it might look like somebody poured it on the floor when they may not have. And you got to think of things like wear patterns, traffic patterns, people walking through an area. That's going to cause that can cause this melted fuel, so to speak, to come down into that area. So look at the floor patterns and understand that. And that's why you have to have and confirm these things by the laboratory analysis for the ignitable liquids. Uh, think of intentionally set patterns. Normally, your pour patterns are going to be more narrow, more linear, that kind of thing. And if they're on porous surface, like you might, we talked about it, you might get the wicking on the edges of it, and the edge patterns, uh, and even donut patterns. When you find like if somebody pours something onto a floor, you might find the outside area burned, where the inside where it's poured is not burned because it's cooled off by the liquid itself. Uh, and we talk when we talk about looking at fire patterns, they tell and retell the story. Uh, the different sequences, the ventilation effects of the fire, and the different packages in there. You have to think of fire in things like movement versus intensity. Basically, movement patterns are those that moving away from the area of origin, where basically it'll take you back to your area of origin, where your intensity patterns, they're produced, made by the flame and the hot gases of the plume, which might be different. You're going to have on intensity fire patterns, you're going to have lines of demarcation, surface melting, oxidation on surfaces, clean burn, that kind of thing. That's intensity patterns, where the moving patterns are going to be like your pointers and that kind of stuff. So things to think about. When you look at developing a hypothesis and such, you're going to be looking at testing things. Did it work the way it was supposed to? I said it did this. How do I test that? How do I look at it and see that it worked? Look for the vector diagrams, and when you measure things, measure the fuel. Basically, it'll tell you that the fire spread, and look at them, because they're going to be different on every fire. Every fire tells a story, but it tells different story. A lot of people like to look at depth of char. I mean, how deep did that fire burn? It's going to tell you the intensity, but it might not tell you where the fire started. There's a lot of things that can create char patterns, including ventilation, uh, accumulation of wood, depending on what kind of wood it was. A lot of different things can do that. And also, even people look at depth of calcinization. Did the wallboard, you look at wallboard like gypsum, it has moisture embedded into it. So therefore, how deep can you measure that moisture? Those kind of things. You want to look at arc mapping. I mean, if you're an electrician, you can look at arc mapping, but if you don't know how to do it, I wouldn't suggest it. But these things, if you have dirt, char, rust around an area, that's not arc It's not arcing that usually cause that. It's usually going to be caused by uh, imperfections in the wire, or loose connections, things like that. So it's all kinds of things there. Uh, as far as that goes, we're not going to talk much about that. But when we look at fire patterns, and when we look at making these observations, we have to definitely understand what it means to find the area in the origin of and fire determination. And we have to make a hypothesis and be able to recognize fire damage and analyze it to make a hypothesis about the area of origin. And through the knowledge of fire patterns, and it's going to take experience, that the pattern analysis and documentation of fire damage, it's something that we're going to have to learn and earn as fire investigators. And when we look at these kind of things, we have to understand what the area of origin is, different types of fire patterns, uh, all these different things. So, is there anything that you guys want to discuss on origins and cause deter area of origin determination? We hadn't really got into cause too much. Is there anything you guys want to talk more about that?
Yeah, if you have a ventilated involved fire, a ventilation involved fire, where everything becomes superheated and causes pretty much all constant involvement. So now there's a lot of charring all over. Will you still be able to see? Let's say that there was poor a poor line. Would that actually burn up in the process as well, since it's going to it's going to char all the walls, the ceiling, and the floor?
Kyle, you want to answer that, or you want me to?
Yeah, when you have full room involvement due to ventilation like that, you're still going to have some good fire patterns in there. I think we get to it later in the other chapters where we're going to do debris removal. And when you start removing all that debris, you'll still be able to see, I think you said pore patterns. The pore patterns will still be there. When you have full room involvement like that, you're gonna go based off a lot of witness statements, what the fire department saw when they were inside there. Like I said, removing all that debris and reconstructing, and you'll be surprised what you find, because a lot of the fire debris that falls down from all the sheetrock and the ceilings will actually protect the floor. So when you start removing all that debris from the flooring, you'll still be able to see those pore patterns. Um, I'll be honest with, when you guys start doing this, a lot of these structures you walk into, suppression activities are going to destroy a lot of your fire patterns. So it's going to be a little bit more challenging than what you're seeing in these pictures, but it's definitely achievable.
Right, and like he says, you'll find those patterns, even though the entire thing has flashed over. You're still going to have deeper burn where you might have poor patterns, where you might have original fire development, that kind of thing. Does that answer your question?
Yes, sir. Thank you.
Anybody else have any questions? Good question, John.
Thank you.
I can't think of any.
Thanks, Brad. Dan or Ismail or Griselda, Victor? Nope.
I'm good, sir. Thank you.
Thank you.
Cool. So what we're going to do is move on to chapter 15, exactly what Lieutenant Pulley was talking about, Kyle. We're going to talk about debris examination and removal and reconstruction. And what this does, we're going to talk about spoliation of debris. We're going to talk about how something might be excavated, which parts we dig out first, and what's important to formulate debris strategy and that kind of stuff. So there's a lot of fire scene reconstruction that we have to think about. When we think about this, and Kyle, please join in anytime you want. Uh, when we think about debris removal, we have to think of things like uh, fire damaged uh, stuff, contents, collapsed walls, collapsed ceilings, uh, structural members, all these things. So the biggest thing we have to look at is safety on these type of scenes. Uh, and a lot of times, these debris, when you remove it, it keeps us from discovering the evidence that's underneath it. And that's what Kyle was talking about, or sorry, Lieutenant Pulley was talking about a little bit earlier. But when we look for what we're looking for when we remove debris, it helps us locate the point and area or the area of origin, and uncovers ignitable ignition sources. It'll take out hidden fire patterns. It'll help us find those, and even new fuel packages that are underneath it, and it helps us locate the physical evidence that we might need. Basically, we're kind of an archaeologist digging up fire debris, right? And what we're doing is, especially in large fires, is you might have to take this stuff out in layers and document these layers when you take them out, because layers represent the history of the fire, even before they're finished putting it out. So it makes a difference what you see on each layer of this fire. As an investigator, first thing you have to do, though, is determine where you want to, lack of a better way to put it, is excavate, where you want to take stuff out, and why do you want to take it out. If you want to take it out on the far end of the house from the fire, is that going to give you what you need? What kind of tools you're going to need? What kind of resources are you going to need? Uh, and are you going to need to reconstruct once you get those layers out of there? Are you going to want to put furniture that may have been there before back? That kind of, just in order to determine the area or point of origin. Just remember when you're doing excavating, that's the best way I can put it, I guess, is when you're excavating, try to avoid destroying or contaminating potential evidence. It's tough to do. Uh, don't move anything that's going to help you collapse the building or anything like that. So, but the whole idea is to get things and be safe about it. Uh, it's good. It's based on basically the fire movement, intensity, and destruction patterns too. The size, when you find a place to excavate, figure out the size and total area damage, number of rooms or compartments that are there, uh, the degree of damage, the location of damage, and the amount and what it's made of too. Fire patterns a lot of time identify the area of origin. So therefore, are you going to be messing up any of your patterns? So you have to take sequential photographs as you move along. And just remember, these things, you might in one layer find something and the next layer find nothing. So focus on the indicators for the area of origin as to where you're going to do it, and come up with a strategy, a timeline for the history of the fire. Just remember the sequence. It can be figured out. Each layer, you examine it, you document it, and then remove it if it's necessary. If it's not, leave it there. Document with photographs, grids, diagrams. All these things are items you want to use in order to determine moving debris removal. If you have a large area, grids are they give a good systematic examination of a fire, where you're going to get it, and you can number and name these grids, take photographs of the grids, and basically what'll happen, it helps you document the process, and it gives you kind of subdivides it, divides it. Say you have a warehouse fire, it might subdivide it into a manageable segment. You might use string or tape or anything like that to grid it off, something like that, enlarge, and make notes and photographs. Record the grid sequence, how you're going to do it, and sketch that grid out if you're going to have any identification markings or anything like that. Think about it. Do you need heavy equipment? Just understand that you have to use a lot of care when using heavy equipment on large areas, because what you just have to be sure when you do it that you can preserve the fire scene and it doesn't add to safety problems too, and make sure the structure is not compromised by using that heavy equipment. It's not that unusual to get a big what is it, the big cranes out there to move like heavy roofs or anything like that. And the problem is, you want to, with your heavy equipment, you don't want to get them directly into the area if you can prevent it, because you could cause cross contamination. Because these things, and it's the same with fire departments. And I'll throw this out there. It's going back a few chapters, but it's the same with using gas-powered ventilation systems. It can cause cross contamination of from ignitable liquids because there's gasoline in these things. So we have to understand: do we need these large equipment, or do we have teams of hand tools going in there? That's not always going to be. But when you use these smaller teams, it gives you a closer look at the layers and basically better documentation of the layers as they're removed. Layering process and management of that debris, just come up with a plan. And when you look at them, prevent contamination and destruction of potential evidence. It's hard to do sometimes. And have a debris staging area. Put it all the debris in the same area. That way you're not looking for something that you can't find later. During the layering process, you have to answer questions like, where was it before the fire began? Where was that material before the fire began? The fire department might have removed debris, so therefore, where was that before it came out? And look at the direction indicators on the material. Does it tell you which way that fire moved? If you put it back in there, is that going to give you more information? It just might when you reconstruct it. You have to ask questions like, was the debris layer created by the fire or as a result of fire suppression, overhaul, something like that? You have to answer those kind of questions when you're removing debris. Just be sure that the things are photographed in their original position as you found them before removing the potential piece of evidence. A fire debris around an item of evidence or anything should be cleared around it to give a clearer exposure. Look at it more clearly. I can tell you, I've pulled on a what I thought was a burned one of my very first fires that I ever investigated. I was pulling on this thing. It looked like a wire and it wouldn't come loose. And when I started digging, it was a burned rat tail that was about 3 feet long. So I knew that didn't start the fire, but it looked like a burned wire. So therefore, clear around the area, and you can leave it alone if it's not. And that was just me being a rookie. My boss knew what it was, and he didn't tell me. He was just egging me on with that one. So look, when you're taking the layers out, be sure that there's not a chance of reigniting that debris. Okay, because the idea is to be able to look through that debris and even sift through it if you need to. Just remember, if you find white ash in layering, you're going to have more of a complete burn, and basically, it might be from a lack of fire suppression in that area. When you reconstruct it, use the protected areas and other evidence to reconstruct it. The sealing materials, wall framing, might assist us in determining the area of origin. Those pointers or V patterns, you might see them on say 2x4s or something like that if they took them out in a section. Look at furniture and equipment. to figure out the reconstruction of the fire. Large things like furniture, appliances, if you can, leave them intact. And as far as removing debris, look at trowels, whisk brooms, sets, the sieves you use to shake out stuff. I recall a fire in Stafford that I did where we started reconstructing this scene, and it was this whole area of this house was gone, but we started putting up walls that were removed and started putting up and saw fire patterns coming from what looked like a lamp. Well, it was one of those floor lamps and had a glass table on it. After we started moving debris, we found the glass table. And on this glass table, we found something, and there was an uh, electric what do you call it, cord stuck to it. So we started asking the homeowner, what was this? Oh, there was a table there. Was there anything on top of the table? Well, we started asking questions, and she said, yeah, there was a potpourri on thing. That's probably the bottom of the potpourri thing. We started looking, and sure enough, it was one of those potpourri pots because we found glass around it. We're on top of the glass table top, and we ended up determining that she never put oil back into it, and that thing heated up overnight and caught the drapes on fire and ended up burning that whole area of the house. So when we were doing reconstruction, we found these things, and that's how we determined the fire. So remember, you have to use hand tools. Sometimes you might need magnets or uh, any number of things when you're reconstructing and looking at these kind of things. Do you have anything to add to anything like that? And then we'll talk about scene reconstruction. Does anybody have any questions about what we've talked about so far before we go to scene reconstruction?
No, I think we're good.
Okay, cool. So
That's-
when we, okay, did you have something, John? No. So when we go to scene reconstruction,
No, I'm good.
thanks. When we go to scene reconstruction, we have to think of basically it's the relocation of burned materials back to their original positions. That's what we did and what I was just describing to you. It might be identifying and relocation that were removed during salvage and overhaul. You might ask the homeowner or ask the business owner or ask the fire department if they moved it and what was there. Because especially if you see a clean burn or something, or not a clean burn, but a protected area, you're going to have to you'll ask them what was over here, that kind of stuff. It helps you observe fire patterns and protected area patterns, that kind of thing, in relation to things that were in that area of origin before and during the fire. So what you're trying to do basically is recreate the scene with contents in their pre-fire location. Document fire pattern growth, document ignition sources, and identify and document the first materials ignited. And you want to document and collect all that evidence. And it's all dependent on the thoroughness and close attention to detail during the removal of that debris. Uh, you get your information from interviews, even pre-fire photographs. There might be photographs that the homeowner might have prior to the fire that you can see that weren't burned up. Does the fire department, do they wear helmet cams or anything like that? It'll tell you where things were before you got in there. And when we do that, we can draw the diagrams where these things were and take photographs of where they were and where we recreated it. It gives us the exact or close to exact pre-fire. It can also help us find fire patterns in protected area patterns that we might not be able to find otherwise. So things we have to think about when we're reconstructing. After reconstruction of that fire scene is complete, the entire scene has to be documented with photographs, sketches, all these things. And when we look at it, we have to realize that what we're trying to do is recreate that pre-fire to determine where that area and cause of the fire was. So there's not a lot on this. Is there anything you'd like to add what we've gone over today, Lieutenant Foley?
No, I think you hit everything correctly on this one. It's just a systematic approach to removing the debris, making sure you're documenting everything. It's not an easy task. It's something that takes time. You can always get the help from the fire department to do the debris removal. Just be careful with what they do because they're going to want to be in a hurry. So make sure you guide them in the process. Yeah, Norm, you hit everything, but if anybody has any questions on it, feel free to ask.
Yeah, we're here. I mean, we covered 3 chapters, so if you have any questions on any of those chapters, we'd be glad to help you out. And if I can't answer it, I know between the 2 of us, we can come up with some kind of answer. We always have an answer. It might not be the right answer. Anybody, any questions, comments, anything like that? All righty. Well, I want to thank everybody. And also, I want to thank Lieutenant Pulley for being here. That way, he could give us any insight that he might have. And we'll what we'll do is go ahead and cut it off, and I'll get with you guys. If you have any questions, get with me, and we'll see you next week. I believe Lieutenant Singleton's going to be with us next week. So, anybody else? All righty, you guys have a good weekend.
No, sir. Thank you.
Y'all take it easy.
No, sir. Have a good week.